Alright, so the next unit we're going to be working on here deals with Chapter 13. Chapter 13 is states of matter. And of course, when we talk about states of matter, this is nothing new. We're dealing with solids, liquids, and gases. We're going to exclude plasma. We're not going to be working on the surface of the sun here in the next couple of days. So we're going to be dealing with solids, liquids, and gases. And when talking about solids, liquids, and gases, it's always important to recognize what the particles look like, what the atoms and molecules look like at that really small molecular level. And so I found a nice little animation. This is on the harcourtschool.com website. And as you can see, we've got a chunk of a solid here. Just could be very well could be anything. Any crystalline solid could be at any state. It just depends on the temperature. If it's something that is normally a gas at room temperature, if you cooled that down to a temperature that's below the freezing point, of course it would be a solid. But anyhow, we have a solid substance here, and you can see the particles in that solid are in this really tight, regular arrangement. They are moving, and it says that they move very little. They can be moving very rapidly, but they indeed are not moving past each other. They're kind of in this tight, regular arrangement. If I heat up my burner on this little slide here, you can see the temperature moving up. As the temperature moves up, obviously it melts the solid into the liquid form. And the difference here is, again, they're still quite tightly packed together, the particles, but now they're moving past each other. And you can see if I were to follow one, it can slide past each other. We're going to get into more detail as we go through this unit, but this basically allows for the flow. You can pour liquids, the molecules can tumble past each other. Obviously, depending on how easily they can move past each other, you might have different viscosities. Viscosity is a term that we're going to be looking at shortly, but again, a higher viscosity substance would not allow as much flow as opposed to something that's less viscous. If I increase my temperature more on this little animation, increasing the temperature, obviously I'm now going to form this substance into a vapor, or in other words, a gas. Notice now the particles are moving so rapidly, they've been able to break from intermolecular forces. We're going to talk about intermolecular forces. Those are forces between neighboring molecules, but they've been able to break free from that and form this and get away from each other. So you can see there's a large space between the molecules in a gas. And again, this would be any type of gas. I can cool my hot plate here, my little hot plate on my animation. And as it cools, you can see it would condense from the gaseous form into a liquid. Again, you can see the molecules looking as though they are in this tightly packed arrangement, but not neat and stationary, more like a solid. Again, I could cool it down even more and form a solid. You can see it looks very ice-like. I hate to use the word ice because that usually refers to water, but a solid form, again, neat, regular pattern. So, of course, that does a really good job of getting us introduced to what states of matter are. In the past, I've done a little states that matter. Just for fun, we've tried to name as many U.S. states as we can. I don't think we're going to do that right now. If you want to, just kind of pause the video, see how many states you can write in 3 minutes. There's a little hint with the geography of the United States. And of course, there they are. But I'm now going to go to gases and their properties. So talking a little bit more specifically about gases and their properties, kind of how they interact and whatnot. So let's move to that next slide on the properties of gases. I think before that I'm going to go ahead and just pause it and we'll move to the next slide.